DesignCon is drinking from two fire hoses simultaneously. So one of those fire hoses is spewing out signal integrity and high speed and printed circuit board issues, and the other one is spewing out power integrity and power connections and die connections. And they have so far very little connection. I mean, ultimately electronically they're very well connected, but it's two very different sets of people. And so I think that DesignCon is the intersection of those two people, and it actually seems a lot like drinking from two fire hoses. One of the things that I like about DesignCon is that it brings together circuit board designers, high-speed designers, and power supply designers, and now it's starting to incorporate the three domains of SI, PI, and EMI. And so I stay involved with it for that, and I have a lot of friends here. I think we have a meeting of minds of some of the brightest people, certainly in the country, and maybe even some of the brightest people in the world, that are here to openly share their ideas. And one of the things that I really like about that is that I like to share my knowledge with young people, especially since, as you noticed, my beard is getting a little gray, so I'm kind of on the other side. And I really enjoy sharing what I've learned with no holds barred. So this is people just sharing what they know because they want to make you better. My first session was a 3-hour session that talked about measurement-based VRM modeling. So it's about how we get the power supply parameters that the semiconductor industry doesn't want to give us or doesn't have the data for, so that we can construct an accurate simulation model from it. So there's two things about PDN, and PDN is actually two different interactions on the circuit board. There's an interaction of the impedance between the VRM, or the voltage regulator module, and the printed circuit board. And then there's another interaction between the printed circuit board and the high-speed load circuits. And so in our measurement-based model, we know that we can't get all of the parameters based that we need from the semiconductor companies to build an accurate model. And we also know that even if we could, it would result in a relatively expensive model that would simulate very slowly. And so what makes our measurement-based model so useful is that it's a simple model that we can derive from only two measurements. We don't need the secrets from the semiconductor company. It's not a very complex model, and it simulates fast. But it does show all of the interactions between the voltage regulator module and the circuit board, and also between the circuit board and the high-speed circuit. I do have a couple of tips, both for the power supply design and also for the printed circuit board design. And I think that one of the predominant issues that I see in my travels is that engineers, when they design their power supply, they don't actually understand the perspective of the high-speed circuit. So they're designing a power supply without understanding what it is that the high-speed circuits really need from it. And so I think that one thing that would be really beneficial for power supply engineers is if they learned a little bit more about the demands of the high-speed circuit and how it is that influences the performance. The second thing is that I think that power supply engineers need to learn from printed circuit board designers about what is and isn't possible. I'll give you one example, is that I have a customer that was building high-speed FPGA circuits, and they decided to put the power supply on a separate card at the other end of their system. And to them that made sense because they had room on a card that was at the other end of the system, but they had no idea what the impact was of actually routing that power across two connectors, the backplane, and finally getting to the FPGA. So I think that really simply what I said is that I think that power supply engineers need to learn more about system impacts and what it is that their counterparts in printed circuit board design and the high-speed designers are facing. And I think once that they can share ideas, I think we'll have better power supplies and better circuit boards. Let me tell you the best tip that I tell people for power integrity, and this is especially true in the automotive market. And what I tell them is that before they take their voltage regulator design and stick it on a 12 or 16 or in some cases 30 layer board, they really should build prototype level boards that are inexpensive, that allow them to characterize the parts that they intend to use and to resolve a lot of the design issues while it's still just a simple 2 or 4 layer board. They can do it relatively inexpensively and they're able to react to changes fast. I think just like I said for the VRM designers, the best tips I have for printed circuit board designers is to make friends that are VRM designers, I think. I mean, there has to be an interaction between them. I'll give you an example. One of the biggest issues that we see in high-speed circuits is power supply designers like to put ceramic capacitors in their power supply. It makes the noise look really good at the power supply, and it makes the impedance look really good at the power supply. But as we show in our workshops, it makes it look really terrible at the other end of the circuit board because the low impedance ESR of the capacitors makes the printed circuit board a very high cube plane. And so I think that printed circuit board designers need to interact with VRM designers and say, don't do that. We'll take care of the noise at our end of the board because you're hurting us, you're not helping us. And likewise, I think the VRM designers can learn from the printed circuit board designers, and the printed circuit board designers can also learn from the VRM designers. So I think for both of them, interact more. You'll both gain. So one thing PCB designers could keep in mind when they're designing their printed circuit boards is that inductance is the root of all evil. And so we want to minimize the plane inductance. And that means that we want to keep the dielectrics thin. We want to keep them close to the surface. We want to keep the width of the planes wider than they are long, and we can use higher Q dielectrics. I don't think that I've seen many changes in test equipment for characterizing circuit boards, and specifically with VRMs. I think what I am seeing is more awareness of the instruments that are out there and how it is that they apply. And so, for example, I think power supply designers and VRM designers aren't really comfortable with what a vector network analyzer is and why they should use it. Most of them aren't aware of what an S parameter is. They're not really aware of how printed circuit boards influence the performance of the power supply or the system. And so from my perspective, what I see is more customers coming asking for help. I'm seeing larger attendance in our workshops and our seminars. And I'm seeing exponential growth in the products that we make for measuring power integrity. So my newest book, Power Integrity, is it's a little bit different than most power integrity books. Power integrity is really, in my mind, it's about getting quality power to the circuits that need it. And so a lot of people talk about target impedance and high-speed aspects and how those relate to power. My book is a little different. My book is about how we make good measurements and how the noise flows in power supplies, which isn't just from output impedance. A VRM actually has 5 different noise paths, 2 stability regions that interact with the printed circuit boards. And so my book is actually how to understand the flow of noise and how each of those 5 paths interact. How do you choose a voltage regulator IC? That's an interesting topic, and I have a few articles about it, and actually this afternoon I have a paper on it. And so there's a few different things. One is that we need to understand figures of merit of voltage regulators, and there really aren't any today. If you look at how it is that a voltage regulator manufacturer promotes his product, the number 1 figure of merit is probably efficiency, and number 2 is probably physical size. The interesting thing is that the figures of merit that we're using have very little to do with power integrity. We care about things like impedance flatness. We care about dynamic response times. We care about control loop stabilities, and those aren't figures of merit. And so I think that's one aspect. And like I said about the printed circuit boards, I think that one tip is don't choose a VRM, choose 5. Build prototypes of 5. Characterize all 5, and by the time you're done, you'll know which one you like. The second part of my paper today is about all the things that we don't really see. We talk about jitter in high-speed circuits. We know how detrimental jitter is. We don't talk about jitter in power supplies, but voltage regulators also have jitter, and sometimes it's really bad, sometimes it's not so bad. How it is that power supplies initially start up, some of them overshoot, some of them don't. And so in my paper today, we're talking about how it is that you kick the tires of a VRM, both from the perspective of the things that we care about once it's running, and second, from all of those hidden aspects that we generally don't get to see, but can really come out and bite us. The reason that I tell customers to invest in 5 VRMs and building prototype circuit boards of 5 VRMs is when you characterize it that way, you get to see all of those hidden things that don't normally come out and you wouldn't see in a data sheet. but very quickly you start ruling out power supplies because, ooh, I didn't expect to do that, and that's going to create havoc in my designs. And you'll only see that by actually measuring it. So that's what I would say. So at DesignCon, I get to meet a lot of different people, and I get to see old friends and new friends. One of the things that I like coming to DesignCon for is for Sierra circuits, and so we use Sierra circuit boards for our own prototypes, and we enjoy the fact that we know that they'll get it right and they'll always give us the performance that we need.